Hi there, my name is Dan and I'm an SRE at Atlassian. I work on Tome, our internal tool for creating and managing large numbers of SLOs. Today I'll be running through how we automate SLO deployment across the company using Terraform. Tome is our dedicated system supporting the creation, deployment and alerting of SLOs across our software teams. We currently track over 10,000 live SLOs, with about half of those active in production. Centralizing all SLOs in one place has many benefits. It ensures consistency across teams who automatically follow best practices when organizing and defining SLOs. This consistency is important for ensuring that all teams are using comparable metrics. We can also standardize alerting across all SLOs, making it easier to manage and respond to incidents. All the data we collect on SLOs is exported to Atlassian's data lake for in-depth analysis. This provides a deeper understanding of service performance over time, enabling teams to look for insights and guide decisions to improve reliability and customer satisfaction. And finally, we can apply common tooling to simplify the process of defining, managing, and monitoring SLOs for everyone, instead of having every team manage their own. Any improvements we make to the platform trickle down to the existing library of SLOs. The result is a more consistent and efficient management process that lets teams focus more on improvements and less on the measurement side. Here's a look at our tech stack. So Tome provides a user interface for creating and viewing SLOs, but most are managed through Terraform. Users write a configuration in Terraform, which uses our custom provider to talk to Tome's API and provision the SLOs. Tome sets up SLOs using data from Splunk and SignalFx, where all the metrics are stored. The full set of attainment data is periodically sent to a Databricks data lake, and any breach or burn alerts on the SLOs are routed to OpsGenie. Tome has an opinionated approach to SLOs built on capabilities, which you can think of as the key functions or features that a service provides. Each capability is composed of multiple SLOs measuring different aspects like performance, reliability, or availability. This hierarchy gives a high-level overview of the health of the service, while also allowing for more granular monitoring and analysis at the SLO and SLI level. SLOs in Tome are defined using signal flow queries applied to metrics logged in SignalFx. Signal flow is a powerful query language that allows for complex transformations and aggregations of data, providing flexibility for users to define SLIs specific to their needs. Along with the queries, each SLO has an objective. This represents the acceptable level of performance or reliability for the SLO under measurement. We apply an error budget calculation over a 28-day window to calculate attainment, which is standardized across all SLOs. On the alerting side, Tome generates SignalFx detectors which trigger on a standard set of burn and breach alerts and forward them to OpsGenie in real time. These alerts include metadata that can be used to customize the alert policies and rules within OpsGenie. This metadata can include information about the type of issue, the severity, the source, and more, providing flexibility in defining how alerts are routed and prioritized. Terraform is an open source infrastructure as code tool, enabling teams to define and provision resources declaratively instead of manually configuring them. This gives us a single source of truth for configuration data, enabling developers to collaborate more easily and make changes quickly. It also includes a state management system that keeps track of changes and provides visibility into resource dependencies. Out of the box, it has support for deploying resources like servers and databases on cloud platforms like AWS or Google Cloud. We added support for creating SLOs by writing a custom provider for Tome through its plugin system. Custom providers for Terraform are written in Golang and the Terraform plugin SDK. The provider is responsible for authenticating and applying operations through the Tome REST API. We have control over customizing the state file diff process, letting us apply specific validations or prevent execution when an invalid configuration would fail at apply time. Mutating operations are written to be idempotent, meaning they can be executed multiple times without causing any unintended side effects. Here's what a Terraform config looks like in Tome. We have a team that owns a couple of products, including a new AI-powered translator. The product's most important capability is being able to perform the translation, so we've added a couple of SLOs to measure its performance and reliability. Now, the SLO definitions include the objective and the signal flow queries for measuring good and bad events, which in this example are simulated with constants. So I'm going to run Terraform plan on our previous configuration. And this is what it looks like. Terraform's telling me each of the resources that it's going to create based on my config. And it's pretty readable. I can see everything's just being added. And it looks okay to me. So once you're satisfied with the plan, you can execute the changes by running the apply command. Then Terraform will create, modify, or delete the necessary resources to bring your infrastructure into the desired state. And it does this through our Terraform provider by talking to Tome's backend. It applies the changes in the order specified by the plan, and it takes into account any dependencies between resources. And at the end of it, it saves this current state to a state file. So I run Terraform apply. I can see that it's successfully created my team, my product, my capability, and my SLOs. So that all looks good. Now, Terraform uses state files to keep track of the resources it provisions and manages. These state files store information about the resource's current state, such as their configuration, status, and dependencies. I should be able to open up one of those now. By tracking and comparing state, Terraform can apply incremental changes to resources, making it easy to manage and update over time. So, if I were to edit, for example, the name, and then plan again, I can see that if I were to apply my changes again, it knows that it only has to change one entity, which is the product, and it'll be changing the name to my new edit. I can go ahead and apply that. And I can see that it only touched one resource in this case. So I've had an incremental update of my configuration. So that was a quick tour of how we implemented SLO automation with Terraform. Compared to open systems like Sloth, we make different trade-offs. Looking at complexity and simplicity, Tome's Terraform is simpler because it only has to handle the specifics of our setup, but adding support for other systems requires writing new integrations. And then, looking at flexibility and consistency, Tome limits configuration of many standard SLO parameters, but it produces consistent data that can be analyzed comparatively. Thanks for making it to the end, and have a great day.